Good morning, everybody. This is the beginning of our course on public health applications of biodiversity data and biodiversity informatics. And we're very pleased to start this experiment. This is essentially the first completely online course that we will do as part of the biodiversity informatics training curriculum. The idea is that we will take this week 9 to 12 every morning in Kansas City, which is 3 to 6 every afternoon in London, and 5 to 8 every afternoon in Nairobi, and you can guess about other cities. We're going to take 3 hours a day, 3 or 4 hours a day. We're going to go through a bunch of topics related to biodiversity informatics and disease. Probably specifically environmentally or zoonotically transmitted diseases. But that's the purpose of this course. I'm going to give you a bit of an introduction first to the biodiversity informatics training curriculum. So hold on just a moment and I will bring up the presentation. There we go. So the Biodiversity Informatics Training Curriculum is an effort to provide comprehensive digital resources for a field that is quite new. In fact, it's so new that there are no textbooks, there are no degree programs, there are no syntheses or summaries. The Biodiversity Informatics Training Curriculum is trying to produce training materials that will be online and open to everyone. The program began in 2012 and is funded for activity through 2015. So that's the general program. Now, what are we talking about when we talk about biodiversity informatics? We're talking about going from biodiversity to information to knowledge. So here's a bird in a mist net in southern China, right on the Vietnamese border in 2004. That bird comes back to a museum, gets processed into a specimen. This is not the same bird, but gets processed into a specimen. The data get recorded in catalogs, initially, believe it or not, still completely by hand, in nice, neat data catalogs like this one. Until very recently, they then got transcribed into big ledgers like this, like in the 19th century. And those ledgers held at least most of the data in a sense that was intended to be permanent, along with field notes. And those are all housed in a bank vault in the museum that I work in. But nowadays, we're talking about capturing all of these data digitally. So data from new specimens are captured essentially as the specimens arrive in museums. Data from old specimens are being captured retroactively, and that capture process is being done more and more efficiently. Here you can see a technician capturing botanical data from old herbarium specimens. Here we're seeing insect specimens being captured. And once the data exists digitally, then we can enable this process, we can speed up this process using a whole bunch of digital tools that are online or on computer to essentially improve the data and improve the ability for people to interact with the data. And so here you can see a Brazilian project where you're able to make comparisons of herbarium specimens online and interactively as if you were sitting in the herbarium actually handling the specimens. We can add geographic references to data. And so there are now detailed workflows for automating this process and turning a specimen reference, which might be 5 kilometers north of Teresópolis in Rio de Janeiro state in Brazil, and turning that into a geographic reference. And you can see 3 alternatives plotted on this map on the Biogeomancer page. And these tools greatly speed up the process of adding geographic coordinates to biodiversity records. Even so, biodiversity data can be dirty. So look at this map. This shows you a heat map, essentially a concentration of records. And you can see this is from a Brazilian project called Species Link. You can see huge numbers of data points concentrated within Brazil. But then you can also see this vertical line passing through London and a horizontal line passing through, passing along the equator. What's happening there? Well, those are data records that have 0 latitude and 0 longitude. You can also see a cloud of points clustered kind of in the western Indian Ocean. And you might think that's data that was collected in some effort concentrated in East Africa and offshore waters. But those are actually South American data points that have the wrong sign on the longitude, and so they appear in the wrong hemisphere. So this is very typical. This is not bad data. This is normal data. And what this Brazilian project, Species Link, has done is to produce very detailed tool for detecting those problems and cleaning them up. And so here you see a Species Link summary of the holdings of a particular collection. You notice that I have blacked out the identity of the collection. But you can see number of records, and then down here, for example, number of records with an uncertain of country or state. There are 3,032 with suspicious names of countries or states, or any record that has latitude and longitude numbers equal, like 10 degrees latitude, 10 degrees longitude. Well, there are 9 records like that. So those are records that one would want to check. And these tools that the CRIA group has developed for Species Link are very, very useful in developing that level of interaction with the data. And one can then even track one's progress. Look at these graphs. In this case, looking at the total number of records in the data set. But then look here down in the suspicious genera. You can see that there were upwards of 11,000 suspicious genera in this data set, and some hardworking curator or collections manager worked through those problems and reduced that number to below 2,000. So we can then go farther and integrate those digital data. So here, again, looking at the Species Link project, you can see 251 collections online, which is 5.2 million records. I think the Species Link project is now upwards of 7 million. Of those 5.2 million, 2.1 million have georeferences, and they refer to almost 400,000 different species names. So this is a huge amount of data. And there are global efforts like GBIF where they're dealing with now 500 million records online. So this integration is a wonderful way of linking institutions that used to be far apart. This map shows you the different institutions that are linked together via the Species Link project in Brazil. And this technology allows the creation of what's in effect a virtual world museum, which is to say collections and data resources around the world can be integrated virtually and be turned into a single global, or in this case, national data resource. And so again, there are the numbers that I told you about earlier. So this is a really exciting time for biodiversity collections. There are lots of new possibilities, and lots of possibilities both on the front of curation of the data, but also research based on those data. But there are large-scale challenges still ahead, and we really need to think very carefully about what is the way forward with these challenges. The underlying principle of this project is that knowledge is power, which is to say we can enable communities around the world to develop very exciting information products, provided that they have free, open, and efficient access to data, information, and knowledge. And so essentially that's the motivating force behind the Biodiversity Informatics Training Curriculum project. Just to give you an idea of the magnitude of the challenge, here's a paper that was published a few years ago by myself and some colleagues, and essentially what I tried to do was outline what are the big questions for this new field. And perhaps the most interesting thing that we did was to develop this very complicated figure. The blue squares are fields of inventory, fields of inquiry. And so you can see information about genotype, about phenotype, about interactions amongst species, about interactions between organisms and their environment, and organisms and humans. And so those blue boxes are all about the natural world. The orange boxes below them are then the sorts of information products that can come out of analyses of these data. And then the little notes that are tagged onto each of these boxes, those notes indicate specific realms of data that have to do with biodiversity. And so those realms of data, it might be sequence data from GenBank, it might be occurrence data, observation status data. Those are all realms of data, data streams that can be brought to bear on these questions of biodiversity informatics. And one of the things that we noticed in developing that analysis is that those realms of data, those data streams, are very isolated from one another. And that's a big problem, because we can't, for example, ask questions about how genes respond to environmental variation and how those interactions might respond to human effects on landscapes producing biodiversity loss. So many of the most interesting questions are at the outset off limits to us simply because those data streams are unlinked and disconnected. This is another view of the same question, and what I'd like you to notice in this external analysis and data services level, you see many of those same data sets, genetic data, phenotype data, environment data, but notice that those different data sets don't interact readily. So in that same paper, what we noticed was that this field has largely been driven by what is possible and not by what is interesting. So the top circle here is technology, the left-hand circle here is data availability. And what we point out in that paper is that technology and data availability have driven many of the ideas and concepts that are being explored in this field of biodiversity informatics. And really, now look at the gray arrows, really the way the field should work is that the ideas and concepts should drive the development of technology and drive the development of data resources. But that's not how things have worked. It is how things should work, but it's not how things have worked. Biodiversity informatics consists of a huge number of initiatives. It's a virtual alphabet soup. We have everything ranging from the Encyclopedia of Life to national initiatives like CONABIO, SANBI, and INBIO, to global initiatives like GBIF and the Convention on Biological Diversity. But too often, these different initiatives don't really talk to each other enough. So when we talk about BI initiatives, biodiversity and informatics initiatives, what we're talking about is connecting information streams. And we really should have a set of basic requirements. And this applies to initiatives that are about informatics, initiatives that are about biodiversity conservation, and for this course, initiatives that are about public health. But we should always insist on primary data streams versus secondary data streams. We should insist on research grade data versus for show data or play grade data. Essentially, we want the very highest quality data to be in the hands of everyone. And when we develop a new initiative, when we add another element to this alphabet soup of initiatives, we have to make sure that those new initiatives are genuine improvements in the infrastructure of science and not just what we might call smoke and mirrors, illusions that look pretty and look interesting but don't really make a major difference. When we talk about research grade data, we're talking about data that have not been dumbed down. They have not been simplified, organized, synthesized, or summarized. It's true, those data, those secondary data are easy to interpret and understand, but usually they're not sufficient for detailed analysis. We really require these research grade data, primary data, data on which a scientific publication could be based. When we talk about infrastructure improvement, I'll just give you a list of adjectives and descriptors. The infrastructure has to be effective, efficient. It has to retain solid roots in, as I said, the primary research grade data. It has to be sustainable, that is to say it shouldn't disappear 5 years from now or 2 years from now. It has to be reliable and publishable, and hopefully that infrastructure will also be novel and inspiring. I'll give you an example, and this is not intended to offend or criticize. This is just an example. Here's an NSF-funded project called Map of Life. And you can go to the Map of Life website and you can look at some really neat data. This is about Afropavo congensis, which is a really neat endemic pheasant in the Congo Basin in Central Africa. And again, you can see all these data together from all these different sources, but I still haven't found a way to download anything. And so this ends up being pretty pictures, but it doesn't do anything as far as enabling real progress. So when we talk about biodiversity informatics initiatives, my question will always be, as a practicing scientist, does that initiative work in terms of making your research or your analysis more effective? So back to biodiversity informatics. This is a new field. There are no existing textbooks. There are no organized training resources. There are no established comprehensive programs. Like there's still nowhere where you can go and get a doctoral degree in biodiversity informatics that gives you a complete overview of the field. There are very few training resources. We see isolated in-person training courses. There are a few resources out there, but nothing comprehensive. And yet there's a great need. Managing natural resources, biodiversity conservation, and again, for this course, developing interesting public health information resources based on biodiversity information is a crucial, present, recent question. And so we have a great need for this field and the products it can develop. And the question is whether this field is going to step up and make a difference. So in terms of technology, training in person is always best. We can always communicate best by meeting in person, working together, and learning from one another. But we can meld that in-person training with some online training, which we're going to explore this week as a full course. We have some really interesting, simple technologies that we can use. For example, YouTube allows us easy access to most all of the world. It allows us the possibility of translating and subtitling video resources so that people who don't speak English, sorry I'm speaking in English today, so that people who don't speak English easily can also have access to the information. And we can provide content globally with almost no expense and very little effort. So what's the idea? In-person training courses, digital video of all of the content. We publish the videos to YouTube. We transcribe to English subtitles. We translate via a crowdsourcing platform. And we provide ancillary information, literature, example data sets, whatever, via web links. The JRS Foundation invested in this idea as of June of 2012, and we've been working hard ever since. The curriculum so far counts on information that is introductory, classes on cleaning and enriching biodiversity data, publishing biodiversity data, niche modeling, analyzing biodiversity data, building biodiversity informatics institutions, capturing biodiversity data, and upcoming courses on national biodiversity diagnoses, biodiversity inventories, and conservation implementation. Those latter three courses are coming up in 2015. In the future, we'd love to extend this idea to other fields, to other regions of the world. The present efforts have been restricted to Africa. We'd love to do in-person courses taught in other languages, obviously with other sets of experts with different language capacities. And we'd very much love to develop this eventually into a cooperative network of graduate programs that could make possible full graduate study in this field. So just some of the resources that have been developed so far. We have an online electronic journal, open access, called Biodiversity Informatics, which gives us a platform for discussions and interchange about this field in a formal academic sense. We have a YouTube channel now with lots and lots of videos. I believe it was over 700 last time I checked. It's seen more than 34,000 views and has more than 300 subscribers. Here's a view of the accumulation of viewership over the course of this project. You can see we've had weeks where 12,000 minutes of viewing have taken place, and hopefully we'll break that record with this week. We have an online seminar series. It's the last Thursday of every month. You can watch an expert give a presentation in this field. In fact, Thursday, partly in conflict with this course, we have a very interesting seminar coming up from a Chilean scientist, Sergio Estay. And we have a Facebook page with more than 2,000 members, which we use simply for exchanging information about this field. Here are some critical links, and this presentation will be made available to you. We'll put them up on a link and put it on the event page shortly, so you'll have access to these links. So that's a very quick introduction to the Biodiversity Informatics training curriculum. Now I want to give you a very brief introduction to this course. Essentially, this course is going to run this week only. Again, it'll be a 3 to 3.5 or 4 hours per day, which is to say, if any of the presentations run over, like this one will be in 3 minutes, if any of the presentations run over time, we may go a little bit later than noon my time and 6 p.m. London time, just so we're not cutting off. So what we're going to be taught about is public health applications of biodiversity information. Now, these questions are everywhere around us. If you look just at the news in the last few years, why are we seeing Ebola being transmitted very broadly in West Africa for the first time? How and why did chikungunya just arrive in the Caribbean? And how did West Nile virus go from being an old world disease to New York City in 1999? And then here in the US, what is hantavirus and where can it occur? That was always an old world disease also. So these questions are all around us. It's about emerging infectious diseases. Most of these questions that we can deal with in this course will be about zoonotic diseases. Some of the tools can be used for environmental diseases as well, but let's focus chiefly on zoonotic diseases. Disease and biodiversity phenomena. Here is a life cycle for leishmaniasis. And what you can see is interactions between pathogens and sandflies and mammals. And in fact, this life cycle is quite simplified because the only mammals that are shown are dogs and humans. And really there's another whole dimension to this, which is wild mammals that may or may not also be involved. Here is trichinella, another zoonotic disease. And notice that here we have involved the pathogen, but also rodents. And then